Alright guys, and welcome to the beginning of our next chapter on optimization. So this is a pretty exciting chapter, and here's what optimization basically is. It's how do we find minimum and maximum values of a function. So here's what I'd like you to do in your paper. I want you to draw a continuous function just on some interval a to b. And then what I want you to do is to mark the highest point on the graph. So this shouldn't take you too long. I'll just say, here's our graph, here's A, here's B. You could start and end your graph however you want. Go ahead and graph it and then mark the highest point. Okay, now there are several ways you could have done this, right? You could have maybe done something boring where you just like started a point and went up. Or maybe you started a point and went down. Or maybe you did like a bunch of shoop-de-whoops and did something like that. Now, no matter what you did, if you want to mark the highest point on the graph, so that'd be here, or this would be the highest point on the graph, one of the things you're going to notice is no matter what your graph looked like, that highest point always occurred at either an endpoint or a local maximum. Hopefully that's something you guys recognize. And that's going to be a big topic for today. But before we do that, let's get into something called an extreme value theorem. And by the way, this idea of a highest point on the graph, that's what's called an absolute maximum. Just remember, an absolute maximum is just saying on some interval a to b, what's the highest point on the graph? Okay, so here's what the extreme value theorem is. You've learned the mean value, you've learned the intermediate value theorem. The extreme value theorem says this. If your function f of x is a continuous function on the interval from a to b, there is some point x equals c where f of c is greater than or equal to f of x for all x on the interval from a to b. Okay, and what that means basically to some f of c is greater than or equal to f of x, that just means you have an absolute maximum at x equals c. So what this statement is saying is if you have some function that's continuous, there's always some value that is the highest point. And similarly, there's always some value that is the lowest point. So that's what this is saying. There is always going to be a highest point. And specifically, we call that the absolute max. And like I said, the opposite of this is also true. There is always a lowest point. So there's always some point where the value of the function at that point is smaller than or equal to all the other values of f of x. And that is an absolute min. So as long as your function is continuous on some interval, you will always have an absolute max and you will always have an absolute min. Now, the curious among you are asking this. And the big question that we're going to have today is how do we find the location, and I guess even the value of this absolute min and max. Okay, so how do we find where's the highest point and where's the lowest point? And here's the answer that you're gonna need to do. You're gonna basically need to, and this is for every kind of problem you do in these, you're gonna need to check the endpoints, and then you're gonna need to check the critical points. And particularly in the critical points, we need to check the local mins and maxes. Okay, so let's get to some example problems. And we'll be doing tons of word problems over the next like 3 videos or 4 videos or whatever. But let's start with just some examples that just have simple equations. So let's say you have y equals 6 plus 2x minus x squared. And we're going to try and find the absolute minimum and maximum values on the interval from 0 to 3. Now, anytime that you have to find a minimum and or a maximum value, it's actually the same process whether you're finding a min or max, and the process is very straightforward. First step, you're going to find all the possibilities. And again, there are 2 categories of these possibilities. The possibilities are the endpoints, and we need to find the critical points. Okay, so in this case, what are the endpoints? Well, the endpoints obviously are given right here. You have x equals 0 and you have x equals 3. And then you have the critical points. And the critical points, remember, are when the derivative equals 0. So when we take this derivative, we get 2 minus 2x equals 0. So that happens at x is equal to 1. Okay, great. So those are our possibilities. I found the endpoints, I found the critical points. That's the first key step. Now the second step, and the way we're going to answer the question, is we just need to find the value of the function at each point. Find the value of the function at each point. And then we'll have to make sure we answer the question. So the question asks for the absolute min and the absolute max, so we need to find both those. So what I mean by finding the value at each point is basically just plug in each possibility. That's it. Okay, so we're going to go ahead and plug in each possibility. So I'll just plug in back to this original function. I'm trying to find the minimum and maximum of y. So I need to go ahead and plug in and figure out what's going on with y. Okay, so when I plug in 0, my y equals 6 plus 0 minus 0, my y is 6. When I plug in 3, my y is 6, plus 6 minus 9, so my y there, 12 minus 9, is 3. When I plug in 1, my y is equal to 6 plus 2 times 1 minus 1, so my y there is equal to 7. Okay, so once I found my possibilities, my endpoints, my critical points, now let's go ahead and just plug in, we plugged in already, and then let's answer the question. So the question asks for the min and the max. So this should be pretty straightforward. Which one is smallest, which one is biggest? So that's going to be my minimum value, and I would write this out like this. Put the minimum value of 3 at the point x equals 3. Specify, here's the value, here's the x where it occurs. Here we have the minimum value, that should be my maximum value of 7, which occurs at x equals 1. Okay, so that's how we do this type of problem. Let me give you one to try on your own, and then we'll talk about it as a class here. So let's say I ask you to find the min and maximum value of f equals x cubed minus 12x minus 2 on the interval from -3 to 3. Okay, so we find the minimum and maximum of this function between -3 and 3. Go ahead and pause the video and take a minute and try and work this out in your paper. A couple minutes here. Okay, so hopefully you looked at this and you said, okay, I'm going to do my endpoints, I'm going to do my critical points. All right, so my endpoints here, of course, those are given. That's x equals -3 and x equals 3. My critical points, I find the derivative and I set it to be 0. So that's a 3x squared minus a 12 equals 0. So that means 3x squared equals 12, getting ahead of myself, x squared equals 4. So my x value could be 2, or my x value could be -2. Now, I do notice that both of these are between my endpoints. If I only wanted to find the min and the max value between, say, 0 and 10, I wouldn't concern myself with the solution -2, just because it doesn't matter. It's not the interval we care about. But both of these are between -3 and 3, so I need to consider both. So now, my first step, which is already done, I went ahead, I found my possibilities. And now at each one, I'm just going to plug in to find f and then answer the question. And this is true every single time, whether you find a min, a max, or both. You always find the possibilities, you plug them in. Okay, so let's go ahead and plug these in. So f of -3, gross. So that's going to be -27 plus 36 minus 2. So I got +7 for that. Okay. When I plug in 3, my function for f of 3, 3 cubed is 27, and then minus 36 minus 2, so that turns out to be -11. Okay. So when I plug in 2, my f of 2 is equal to 8 minus 12 times 2, so minus a 24 minus 2, so that's -18. And again, I'm trying to find the min and max of f, so I plug in for f. When I do f of -2, I have -8 plus 24 minus 2, so that equals 14. Okay, and again, these min and maxes could occur at endpoints or critical points. It is mandatory that you check all of them. On the AP test, they expect to see your work with you checking all of them. Okay, so to answer the question, which asks for min and max, the minimum value I got, it's right here, it's the smallest one, is -18 at x equals 2. And then as for my largest value of the 4, the 14 is the largest. So my maximum value is f of 2, f of negative 2 being equal to positive 14. Okay, so again, that tells you the highest point and the lowest point on this interval. Let's take a look at one more with an e in it, just because this is going to look a little wonky here. So let's say, for example, I ask this. So at what x does the minimum value of x e to the negative x occur between x equals 0 and x equals 2. So we just have to find the min, not the max. But we're going to, again, do the same process. The question's asking for an absolute max or an absolute min. And if they don't use the word local or relative, they mean an absolute. So we're going to go ahead and find our possibilities, which, again, are the endpoints and the critical points. And then we'll go ahead and plug those in. Okay, so my possibilities here, the endpoints, of course, are obvious, right? They told us we're looking between 0 and 2. They're always going to give you those. Or if they don't, there aren't any endpoints. So like if they give you no endpoints, you just don't have any. So that's easy. But the endpoints here are, x equals 0 and x equals 2. My critical points, okay, let's use the product rule here. So if my function is x e to the negative x, I need to take the derivative and set it to be 0. So when I do that, my first derivative, I'll use the product rule. So first times derivative of second, so times the negative 1, plus the second times 1. Okay, great. All right. So let's see. So I'm setting negative x e to the negative x plus e to the negative x equal to 0. This might look like a humdinger, but remember the way you solve these problems is you factor out e to the negative x. We're left with a negative x plus 1. Okay. So then either e to the negative x equals 0 or negative x plus 1 equals 0. Well, in that case, your x is just 1. And this never happens, right? E to a power is never 0. So we have three possibilities. We have 0, we have 2, and we have 1. So now we have to plug in. So this is my function I'm plugging in that I'm trying to find the minimum value of. F of 0 is equal to 0 e to the 0. Okay, well that's obviously 0. F of 2 is equal to 2 e to the negative 2, also known as 2 over e squared. When I plug in a 1, my f of 1 is equal to 1 e to the negative 1, also known as 1 divided by e. Now, if it asks for the maximum value, we'd have to plot a calculator, or remember that e is like approximately 2.7, which you should know anyway. But we're just finding the minimum, right? E is positive, e squared is positive. So that means that my minimum value is 0 at x equals 0. Okay, so that's how you do these problems, guys. Find the possibilities, the endpoints, the critical points, and plug in. Every single time, whether you find a min, a max, both, you need to do this. Okay, bring me some questions to class, and I'll see you guys soon.